All right, finally, let's do this. Holy cow, what a lot of drama. A lot of drama. All right, let's see. All right. Finally. Thanks, guys. All right, everyone. Finally. Holy cow, that was a lot of drama. I hope you guys can hear me okay. If not, I'll switch my microphone over to this guy. Ideally, but I have the air conditioning right above me, and that air conditioning right there is precious. It's absolutely precious. So I'm going to leave the AC on. I just don't want it, blowing really hard down here. So today I got some new USB test equipment, and it kind of solved some of the problems that I had last time when last time I did a USB video. People were talking about how I didn't have a load on, and they were talking about, there's a lot of variables. Wouldn't you know it, somebody out there thought of a lot of this stuff, and this stuff is widely available on pretty much any Amazon store. USB, they have this kind of stuff. So what I have here, this is basically a USB multimeter, this one right here, and this right here is a detachable load. Now, the only modification I had to make is right up here on the positive terminal. Before it gets to the switches, I soldered in a test lead so that I can catch things like artifact. Things like artifact, which could be introduced or created by the USB itself. Now, the reason that I go into USB is because a lot of USB systems are designed like crap. They're absolutely horrible. And some of those would be probably like this guy right here. I really want to dissect this guy and show you. You can kind of tell by the weight that it's not very heavy. And here is the inside circuits of two such USB systems. Like, let's see, where's the J shape? I think this one right here. Yeah, that's what you're looking at right there. So it's something like that from the inside. And these two terminals right here are the AC input. And this one over here, it's got just a couple small solder terminals, I think, for the AC input. And that's it. So some of them can be very complex, and some of them are going to be very, very simple. And last time I did a USB video, one of the things that I found is that the Amazon power supplies, like this guy right here, these were the worst. It was the worst, the absolute worst. So bad, in fact, that I honestly wouldn't have it in my house. So these ones right here are a little bit more complex, very similar in structure. Notice how this one here doesn't really have a microcontroller on it, but this one here does. It's just very interesting, the steps that these companies take. Some of them have really good fusing, some of them do not. This one here has isolation slots cut in. A lot of stuff that's really interesting about these. And USB tech is one of those things that's changing. So one of the reasons I wanted to do this video is not only because the power supply itself is different, but one of the things I've noticed is that when using USB 3.0, they get really warm. And if you guys know anything about computers, the faster the computer goes, the more electricity generally they burn. And that's because as you increase frequency, you get also parasitic losses. You get quite a bit of them. And for every clock cycle, that's a process, and it has to be refreshed. So you increase the amount of clock cycles, that's the amount of pulses of electricity that you have to send through the circuit. So if you increase the frequency, generally they decrease the size of the components, the die, and they do that to save power. So anyway, one of the things I wanted to get into is how much electricity different USBs burn. And I want to talk about transfer rates because that's one of the big things about USB. You're going to get a variety of transfer rates. Now, can you guys hear me okay? Should I switch to a different microphone by chance? Can you hear me? Okay, hold on. Let me see if I can switch up that microphone. One of the things that is an absolute pain in the ass is YouTube. YouTube is such a pain when it comes to switching audio tracks and stuff. Man, I think while the stream's running, they're going to lock me out and I can't change it. All right. Well, that's just going to piss me off. It's little things like that that just kind of irk me. I've been fighting this system for, I don't know, probably 10 minutes or so, just trying to get this all set up, all right? One of the other things I wanted to point out is most everybody that won during the last giveaway, only one person wrote me with their address and their contact info. And if you're one of those people, take a look back at that video. If you're one of those people, come on, guys. Let's get this stuff in the mail, all right? Anyway, let's get back to it. So about my test set here. This is the multimeter. This is the load. This is just a 2.0 extension. That way there, I can bring it closer to the camera. You guys can see a little bit more clearly what's going on. In the back, I have an oscilloscope set up so that we can also check and see what's really going on with the clarity of the signal, because they're not all the same, and you're going to see that. Also, I have a Samsung Note 10, and I have an Ultra 22 right here, and I also want to see charge rates, and charge rates based on the cable. That's something else that we can do with this little USB digital tester, is we can check the charge rates of this phone and that phone, because these are both fast charging phones, so they should be pulling as many amps as possible. So what I would like to see is if USB 2.0 cables or a full USB-C, or let's see, here's a USB-C of a better quality. I have a USB 3.0, which has got the extra pins in it, USB 3.0 to USB-C. And one of the last cables that I have is a regular, where is it? Okay, I got a USB-C to USB-C. We got a whole bunch of them, guys, and we are going to just run through a bunch of these little tests and show you really what's going on with your USB system. Because depending on the cable that you're using, you are probably not charging your phone at the fastest rate possible. And if you are like most everybody else in the world, you probably use whatever charger is available. And I'm going to show you for a fact, using this little tester right here, hopefully I can get it all in frame. With this little tester right here, I'm going to show you that if you use the wrong charger, you could be either hurting your phone or you could be not charging it correctly or fast enough. All right? So there's a lot of factors to go in. So let's go ahead and start it off, guys. So of the USBs, I got another Amazon. I have a generic Chinese adapter. This one here is rated at 0.5 amp. Let's see, this one here is rated at, 1 amp, something like that. I've got a Samsung charger here. It's rated at 2 amps. And some of these Samsung chargers are going to be really interesting because ones like this guy here, it uses USB-C. And USB-C, let's go ahead and just talk about USB-C first off. If you guys didn't know, USB-C is obviously the best of the best. It's not just because of the port, okay? It is the best of the best because, hold on, let me rotate that a little bit more. That's driving me crazy. All right, USB-C is the best of the best because it is auto-negotiating. So it auto negotiates the voltage. Like this USB-C, let's see, where was it? This guy right here. USB-C can be up to 20 volts. How crazy is that? So it can negotiate up to 20 volts. So you can use a USB-C to charge something that is more than your typical voltage. A normal device is 5 volts or less, and a lithium ion cell is 3 point something volts. So what you do is you take a 5-volt signal and you attenuate, or you cut that voltage down using fancy circuitry. You cut that voltage down to a ideal 3.7 volts for charging those lithium ion batteries. So that's normally what happens. But since USB-C auto negotiates voltage, it also auto negotiates master and slave. So no other USB before this did this. Master and slave means that I can connect one phone here. In fact, let's do it. I can connect one phone to another phone, and I can charge one device from the other. Look at that. I'm charging one phone off the other using a USB-C. Yep, see, there it goes. It's going into charging mode. But also, I can transfer data bidirectionally. So I can make this one the master and send data. I can make this one the master, and I can make it send data. But we can't send data in both directions. I might be wrong, but you can't send it in both directions. That's usually why the software that manages this USB-C connection, it asks, would you like to send or receive? Because it's now setting the bus or the network, it's setting this device as the master, this device as the slave, and there you go. So that's normally what you do. Connect both of them up, transfer data, whatever you got to do, press on. That is only possible with USB-C. But also, I can fast charge. I can charge way faster with USB-C than with USB 2.0. And I'm going to prove that because this funky little device, it has a multimeter in it, and we are going to check not only voltage, but also the current. Okay? And in the background here, I'm going to go ahead and have my oscilloscope set up so that if we see some anomalies like a voltage drop, or if we see under load, one of these guys starts pulsing like erratically, because some of these components, if they're cheaper made, you start heating them up, they will start acting erratically. Now this one here, since there's no microprocessor on there, it's all pretty much stupid. I would say that this one is probably one of my candidates for giving a bad signal. I don't have the cord hooked up to it at the moment, but that is exactly what I would expect, which is going to be this guy right here, right? I think. Close enough. So let's go ahead and start it off. I have nothing else plugged in, so there is no signal other than I have LED lights above me, and the LED drivers will give a pulsing. That's okay. So let's start right out. The first one I'm going to start with is a Nintendo USB charger. And you would think that the Nintendo USB charger is going to be probably really powerful because it's what, 3 amp? 5 volt, 1.5 amp. Now, in my setup for this video, I already found one protection feature of this Nintendo because I overloaded it. I really did. I really wish that was a little brighter. That's horrible. All right. All right, let's see. Can you see that? Okay. So we are currently running 5.06 volts. We're at 0 amps because right now there is no load. And right here on my load, I have 2 different selectors, and we can put a variable load on this guy and test it out. So what we're going to look for is when we put a load on it, you're looking for the voltage to drop. So that is telling us that this guy back here can compensate, all right? Because if it's designed well and it can handle enough amps, it will compensate for the load and it will increase output. So let's go ahead and kick on the first load. You can see it dropped immediately down to 4 volts at 1.75, 1.76 amps. That is not very much power, guys. Not very much at all. And you can see it's hanging right there around 4 volts. Now these load resistors are getting a little bit warm. All right, going to. That's what's going to happen. So what I'm going to do is I'm going to overload this system by clicking on both loads. Notice how it shut off. So there is a protection circuit in the Nintendo unit right here, and it shuts everything down. So what I'll do is I'll unplug it, and if I plug it back in immediately, it will not work. So this guy here has to cool down. It's got some sort of thermal overload protection, kind of like a circuit breaker for your house. And once it cools down, it's going to up and run. We're going to be just fine. All right. So this one here is a USB charger for DJI. And this one here is 5 volts, 3 amps. So this guy can handle some power. Now it feels really dense. And what I'm thinking, based on my experience with Apple, the Apple has the little cube. It's almost identical to this. They have one circuit board, and then they have another circuit board, and then they have another circuit board. It's really sandwiched in there, really good. This one feels dense enough that I think that's what's happening. So let's go ahead and pop it on. Let's shut off both my loads. All right. I've got 5.1 volts. Switch on the first. I'm down to 4.63 at 2 amps. So it's already way outputting more than this Nintendo. It's doing far beyond. And I switch on the second load. Now I'm at almost 3 amps. That is amazing. This little box right here is keeping up with almost 3 amps. And I'm at 4.43 volts. So it's already keeping up pretty good. Let's come back over here. We're going to hit auto. I'm going to shut off channel B because we don't need that. There we go. And now I'm going to go ahead and take it down to the smallest division. Okay, I'm at 10 nanoseconds. And what this will tell us, if you see a lot of ripples over here, then that means that there's definitely a problem. Look at this. This guy's keeping up. Holy cow. Those loads are definitely getting warm too. So this little charger right here for the DJI, it's close to spot on. It only dropped about half a volt with 3 amps worth of load. And notice my ripple up here is minimal. And so this is going to be one of my better power supplies. Let's try another Samsung. These are the type of chargers that come with your phones, or they used to anyway. So I imagine that this is going to be a better USB source. Okay. So this one is not fluctuating hardly much at all. Let's see if I can bring it up so the camera can see it. It's sitting almost exactly at 5 volts. Spot on. And you can see that there's almost no ripple on it. It's beautiful. Now let's see what it does under a load. I flick on the first load, 2.1 amps, and we're sitting at 4.77 volts. 4.77 volts. That's really incredible. Hardly any voltage drop on that little guy right there. So let's go ahead and kick on the second load. I'm down to 3.4 volts at 1.72 amps. We've clearly overloaded it. Yeah, these guys are probably over 100 degrees right now. Very, very hot. So this little guy right here for about 1.5 amps to 3/4 of an amp. Amp and 3/4. It's doing really good. It says that this one here is a negotiating power source, because it says that it does 9 volts at 1.67 amps, or it does 5 volts at 2 amps. We did get it to about 2 amps, and it was pretty steady. Oh, look at that. No kidding. It says adaptive fast charging. So if it can take it, then I guess this guy puts it out. right, so this one's one to check later on because I can see the extra pins. Now, if you guys didn't know, that up in here, there we go. Oh, come on. Up and inside, this guy right here, there are some extra pins. There we go. All in the back there. And those extra pins are for USB 3.0 capabilities. So USB 3.0 are going to be the ones that are blue. You can see right here it's got blue. And it will have extra pins up inside. So we're going to test that. We'll check that out. So I'm going to set my adaptive Samsung off to the side so that we can check it out later. That's going to be super cool. But that's one of those things where if you are charging with a USB 2.0 cable like this guy right here, you are not taking advantage of what this charger can do. So use the cable that came with the charger. You'll probably get faster and better charging. Okay, here is another Samsung. It's not the same as that one. Very similar, but not completely the same. So this one says 5 volts at 2 amps or 9 volts at 1.67. Okay, so internally it's probably the same as that one because those stats are almost identical. We're going to press on. Here's my Amazon. Now, Amazon does not have a good history here on this channel because they have horrible ripple, and we might see that in just a moment. So let's go ahead and plug it in. Okay, so we have no load on right now, and I think that is an 1.5 amps is what it's supposed to be able to handle. So let's turn on the smaller load first. We're sitting at 5.4 volts, and it's steady. I turn on the smaller load, and I am at 1 amp, 4.83 volts, steady. We've got barely any ripple whatsoever. So let's go ahead and click our second load on. Okay. So this guy here shut off, even though back here I can see that I still have 2 or 3 volts. So even though it did overcurrent, there's not really circuit protection in there. That's really interesting. So it shot voltage below the 3 volts necessary for the CPU here. But that's funny because there's no real overcurrent protection. It just kept going. It just did it at 2 amps. Huh. It almost seems like it's a fire hazard. Yeah, so I'm going to stick him back here. That's very questionable. Now this right here is a Chinese charger that came with a microscope. I don't expect very much from this guy. I really don't. Because its normal job is nothing's really expected of it. Okay, here we go. We're at 5.03 volts, 0 amps. I do have a little bit more ripple back here, and that's without me doing anything. So let's turn on the lowest load, which is about 1 amp. Wow. Compensation, really good. 4.94 volts at 1 amp. This guy here is jumping around a little bit more, though. Just let it normalize. So it is jumping around a little bit there on the oscilloscope. Okay, let's turn on both loads. And it undervolted, which shut off this guy, but it came on immediately. Let's try it again. Wow. When I turn on the larger load, it goes down to 3.6 volts, 1.6 amps. So at 1.6 amps, that's it. It's done. It's already got such a voltage drop, it's useless. And from that, I wonder how long it can maintain that, because this guy right here, if you put too much load on it, so let's say I want to charge this phone, I find this charger, and I'm like, yeah, let's just plug these guys in. Any modern day cell phone is going to pull some amps. It's going to pull some amps, guys, and we're going to find that out in just a moment. We're going to see how many amps this phone pulls based on what cable I use. And but this guy right here, if I were to use this to charge my phone, it didn't overcurrent, so it didn't shut down. It just kept, the voltage drop just fell right off, which means something could be getting hot in here because it's pulling a lot of amps. That's not good. Let's see. I've got another Chinese charger right here, similar to the last one. It's a little bit heavier. Sometimes, believe it or not, it's crazy. Inside these guys, I've opened them up before, and I found that when they're heavier like that, it's because the manufacturer put something inside this to make it feel heavier. It's true. I've seen it. So let's go ahead and let's plug it. Oh, okay. So this guy here has a ready light. That's cool. I love it when they do that. We're at a steady 5.04 volts. We're doing good. Wow. Okay. So it did shut off the light here, but when I put one load on it, it just killed it. Just killed it. Hardly any load. So on my smallest load here, this little USB charger right here is almost completely useless. It dives down to 3.25 volts. I'm at 0.05 of an amp. 0.05 of an amp. It's useless. So even though you can even see the light dimming right here, and this is a small load. This is less than an amp. Let's take a look. Yep, there it is. Output 5 volts, half an amp. Half an amp. So anything over a half an amp, it just falls right off. Can't keep up. Garbage. All right, my favorite little green guy. I bought this in a hospital gift shop. It's the same type of one that you would find at a gas station or something like that. Let's see how it does. It's extremely lightweight. Okay, I'm at 5.03 volts, 5.04. It's teetering, so not that steady. Let's put the smallest load on. I'm at 0.84 of an amp, and I'm at 4 volts. You can see it's trying to compensate because it was at 3.95. Now it's at 3.99, so it's trying to compensate. I bet you that little is going to get warm, really warm. So that's with the small load. Let's put the large load on. Knocks it out. It's done. Okay. So this guy here is almost completely useless. All right. So now let's change this up a little bit. Now I'm going to do a USB-C. Let's go ahead and see what the USB-C is on this meter. In order to do that, let's see. I hope that this is a good USB-C cable. It feels like it's a good cable. I think this is what, 4 feet, 5 feet. It's not too long. All right, and let's plug it right in here. Okay. Hold on. How am I going to test this? All right. So, fortunately, they included a gender changer in here. How cool is that? So I'm going to pop him back in there to hold it. So I'm going to take this gender changer, pop it over, and come on. Well, something's going on here. So this is the Type-C input. I guess let's try it straight on the adapter. We'll see what happens. It'd be pretty wild if my adapter was blown up. Okay. It's not picking anything up. So let's try one last thing. Let's try a USB-C. And let's try USB-C to the cell phone, and let's see if it's looking to negotiate. Take a look at that. So there you go. That's a little frustrating. So this USB-C adapter, I said earlier that they auto-negotiate. Well, this guy is fast charging my phone right now, but it had to negotiate. So let's see if I can fix that. So let's see, let's pop him. Okay. We're going to put that one right here. And I'm going to put my phone on the other side. And we're going to see, there we go, because it has to negotiate in order for it to turn on the charger. Look at that. See, that's the weird thing about USB-C. And I'm sitting at 8.92 volts at 2.25 amps. So there you go. USB-C, it says 35 minutes until full charge. And that's with a Note, Samsung Note telephone. So it's sitting at currently 9 volts, 2.25 amps. And there you have it. So USB-C does negotiate voltage. It can handle it. It's going to fast charge it. So this phone here is 9 volts. Let's see. This is a Note 10. I record a lot of videos with this phone. Okay, I can actually see it. It started out at 5 volts, and then it stepped up to 7, and now it's sitting at, it's bouncing all over the place. 8.79, 8.8, 2.4 amps. So the telephone tells the USB-C charger how fast it can go, and then it just tries to get there. So there's that. Now let's check something else. So this one here, you can tell it's a really thick grade USB-C to USB-C. I'm going to use a cheaper feeling, thinner version of USB-C. I don't know where I got this cable. I have no idea. Let's see if this guy here can match the specs of this little fat guy. Well, how about that, guys? How about that? It's not charging. It can't negotiate. So this cable right here, even though it's a USB-C to USB-C, it's not the same. Not the same, guys. Wow. Let me try reversing it just in case. There it goes. Weird quinks. It is what it is. Okay, well, this is definitely not that good of a cable. Oh, okay, so this cable here, it definitely has some, probably some data integrity issues. 7 volts, 8 volts, 9 volts. And then you can see it's increasing the amperage. And then as it increases the amps, it has a negotiation problem and it kills the signal. And that's what it's doing. It's in a loop. So we're at 8.8, 1.62 amps. And then it was rebooted and then rebooted and then rebooted. As far as I know, this is a good cable. It's just, it's not a fast cable. And you can tell the thickness of the cable. It feels like a silicone jacket, but it's not as good. So it settled at 8.85 volts at 1.62 amps. So this cable here is 1.62 amps max. Now let's get back to this one. And I'll show you guys that if you use a quality USB-C cable, there we go. I'm sitting at 9 volts, 2.25 amps. So all cables are not equal. Just because it's got a correct end on it does not mean it's going to give you the fast transmission rate. So my phone was having a tough time communicating with the charger over there, and it was having that tough time because it was a bad cable. Or, I mean, the cable itself works, but it can't handle that fast of a throughput and at that level of amps, because as you increase amps, you're probably getting extra noise and a whole bunch of stuff. So now I'm at 9 volts, 9.07 volts at 2.23 amps. That's with a quality USB-C to USB-C. Now, you could argue that maybe it's the length of the cable, because one cable is, what, 2.5 feet, maybe 3 feet, maybe, something like that. You can see it right there. Maybe 2 feet. One cable is 6 inches. Let's see. Let's check something else out. Let's see if I can convert. Let me. Nope. Okay. All right. There we go. So I'm going to go ahead and pull this base out of here. This is just a USB 3.0 female to male. This is a really good part. So this didn't interfere with any of my results. All right. It's probably one of the best components that you can buy. Let's go ahead and put the oscilloscope in the bag. It doesn't matter anymore. Okay, here's my USB-C. Let's see. I have a USB 3.0 cable and I have a USB 2.0 cable. And we're going to test out the amount of amps that we can charge with just that cable. And then maybe I'll check out some data rates. Let's see how fast we can get it going. Okay, so here's all the garbage ones. The Samsung brand chargers seem to be really good. Now, this is a Samsung USB-C. If you have a Samsung USB-C charger, that's the best of the best, man. That can charge your cell phone faster than any of these other ones. So one of the other cool things, these ones here, this is a very heavy charger. This is a 10-port USB charger. It can do 5 volts at 12 amps. 12 amps. So we should not have. So we're going to use this guy here as my power source. Yeah. We're going to use this guy here as my power source, and we're going to check out some other things using the USB 2.0. Let's see. Probably have to do it like that. It's always upside down. Why did they make it like that? That is so frustrating. It's upside down. I guess I can do it like that, huh? All right, how about right there? All right, so right now, at a stable state, it's teetering between 5.37 and 5.38. You'd expect that from a device that can output a few more amps. Let's go ahead and check out these two cables, all right? First, let's start with the USB 2.0. To USB-C, to my cell phone. Here we go. It's charging. Okay, I've got 5.28 volts at 1.38 amps. So notice I'm using a normal USB. It's only shooting 5 volts. It's not shooting the 9 or 8 volts like the fast chargers. And here we are. So that's steady at 1.8 amps. That's probably as slow of a charger as you can get. It would take me, what, 2 or 3 hours? Let's see. Hold on. These Samsung phones are really good at telling you how long it's going to take to charge. It says 51 minutes until full. Okay. So we went from 30 minutes to 51 minutes. Let's go ahead and pull that guy out. And let's try the USB 3.0. I don't expect too much of a change because this is not a USB 3.0 charger. This one's 50 minutes until full. 5.26 and 1.7. A little bit more amperage on this cable than the other one. Just a little. So this one here, this is the type of charger that I use when I'm charging a whole bunch of like electronics. And I do that with these magnetic USBs. You find these on Amazon. They're awesome. And I will have a whole series of these plugged in all the way up and down. See, they come in different colors. See this? I did a whole video on magnetic USBs. Check it out. And let's see, where's the little adapter? Here it is. In order to use these, they take a little adapter that fits in your port. For me, I love that because by putting this adapter in the port, you're only plugging and unplugging once. And the big problem that we often have is that the port itself breaks, and that's from the wiggling around, the plugging, the unplugging, fluid getting in there. By keeping these little guys right here in the port, we can keep from plugging and unplugging. Because what you do is it just connects instantly, bam, and you start charging. These are really cool for kids' electronics because kids will mess up USB ports. So go out and get a bunch of these magnetic USBs. They come with a whole collection of these adapters, and use the correct adapter for your device, and then just have a charge bank like this one right here, and all your cables are sitting there so your kids can just grab it, connect it, instantly charging. It eliminates a lot of that user error, okay? Love it. Anyway, this is the Sabrent USB charger. Found it on Amazon. I love that guy. Love it. And let's see. Here's one of my last ones. This is a Power XL. You can imagine that this is probably a cheaper one. It says 5 volts, 5 amps total max. Well, that's not very much. That's 1 amp per, I think. Let's check it out. Let's see what it can do. So I'm sitting at 4.98. Here you can see it right there. 4.98 volts. I'm going to plug the charger or my load in. Switch on the small load. We are sitting at 1 amp. Switch on the large load. It's sitting right at 5 amps. Not too bad, huh? Almost no voltage drop, which is good. Really good. And let's see. Let's flick both of them on. Wow. I'm actually pretty impressed with this little guy. You can see I'm at 5 volts. I'm at 3.31 amps. This guy here is probably getting really hot. But it kept the voltage steady. Now, why would you want to keep the voltage steady? Well, your charge rate is based on keeping a steady voltage. And when you are charging a lithium ion, it's not a steady charge rate like maybe a lead acid battery or something like that. These guys here will ramp up the charging. So they will start out really, really fast, high current, charging really fast, and then it dives the current down to fine-tune the last few percentages. So when you get to like 80%, that's when it dives down the amount of current. that is shoving into that charging port. That's also saving your battery, amongst other things. So that's this guy. It kept up. Actually, very impressed. That's more XL. I keep this one on my nightstand, and I charge up like my phone and stuff like that with magnetic chargers. This guy's awesome. A little cumbersome because it doesn't sit flat and square. I like this guy because it doesn't tip over. It's weighted. It's very heavy. You can imagine this guy right here. It's I need to like put a plate or something on it. That's what I need to do. I need to put it on a metal plate so it stays standing up, because this guy tips over. Such a pain, but it does its job. Let's try this guy out again. The load. Let's see how it does. Let's see. Everything's off. Remember, this guy here could go to 12 amps, and that's a lot. That's a lot. All right, let's see. First load. I'm at 2.28 amps. It's right here so you guys can see it. 2.28 amps. It's getting warm. Let's look on the second load. What? Did you guys see that? This is a 12 amp charger, and when I put too many amps on it, it just killed it. Now, that makes me wonder, do some of these ports have selective amperage? So it's got like overcurrent protection on some of the USB ports. I don't know if that's a good thing or bad thing, because that other one, I put 3+ amps on it, and it kept trucking right along. Okay, we're even sitting at a higher voltage on this guy. We're at 5.37 volts. Here we go. Port 2.27 amps. Kills it. So this guy is my favorite. It's my absolute favorite charger because it's just a workhorse, and it's got a lot of ports. When it comes to amps, that guy can't do it. Anything over like 2.5 amps, and it just kills it. Shuts the port down. That could be good for fire protection. Could be good. I don't know. It's up to you guys. Now, hopefully this doesn't kill my laptop. We're going to do a test on my laptop using that USB tester. Not with the load. That would be so bad to put that load on a laptop. Here we go. So let's see what my laptop's putting out. I'm sitting at 5.09 volts, 5.08. Let's see what a typical cheap USB stick, let's see what this guy does. Okay, my computer recognizes it, and we're sitting at 0.02, 0.03 amps at 5.08 volts. Not too shabby. I didn't expect much. These are the cheapest of the cheap USB sticks. This is Avante Health Solutions. I keep all sorts of cool stuff on this guy. It's a cool looking memory stick, or USB stick. Okay, let's see. Does the computer recognize it? Yes, it does. There it is. Okay, so we are at 0.02, 0.03 amps. No problems. Powered up. I can recognize it and read it on my laptop. All right, here's the big boy. I love these SanDisk, the aluminum case USB 3.0s. USB 3.0, it always gets warmer. So if it gets warmer, that means it's got more heat, and that means it's pulling more amps. Oh yeah, there we go. So you can see right there, we're pulling 0.18 of an amp. My voltage for my computer port pulled down to 5.03 volts. We're at 0.18 of an amp. So this USB stick consumes, 10 times the amount of power as a USB 2.0. 10 times. Here we go. I'm really kind of surprised about that. All right, so here's one of the things I really wanted to test. This is a USB 3.0. I do believe this adapter is probably only a USB 2.0, so it might not work the way I want it to. But let's go ahead and check a computer hooking up a USB-C. Let's see how much current this guy is pulling. Wow. Okay. That might be a note to self for the future. You can see right here. Oh, there we go. It dived my voltage from my port down to 4.9 volts, and it was pulling half an amp. It was 0.5, now it's 0.39. And my phone says it's going to take 3 hours and 29 minutes to charge from this port. 3 hours and 29 minutes. So I use my computer for charging when I go out in the field, when I'm on the road, when I go to hotels and stuff. And it does take forever to charge my phone. Now that I have this device right here, I know that that is the worst charger that I can possibly have. So from now on, I'm probably going to take one of these little Samsung fast chargers, and this guy here is going to be in my bag, because this, it's first off, it's pulling a lot of current from my motherboard, right? So pulling a lot of current from your motherboard is probably not a good idea. It can do it, but it's not a good idea. And these new phones, they're pulling a lot of amps, right? So we're shooting down at 4-point-something volts at half an amp, and it's taking forever to charge. So that's with the little skinny USB-C. This is USB 2.0. So now let's see if my USB 3.0, how many amps this guy's going to pull, because that last one pulled my port down to 4.5 volts. That's a big voltage drop. Okay, ready? Let's do it. Woo, there's definitely a difference there, guys. So right here, let's see if I can get it framed. So I'm shooting 4.8 volts at 0.79 amps. 0.79 amps coming from this USB power port right here. That's incredible. So there is a current difference between the cables. So this little cable right here is still going to take hours to charge my phone off the laptop. And that's a USB 3.0 port. So USB 3.0 port, you would automatically think, oh, this guy can probably charge quite good. No. I learned something today, guys, because I always thought that the USB 3.0 ports would charge faster. I just did. So now I'm curious about the USB-C port, because I also charge my phone off the USB-C. And so I'm going to lose this camera right here, but I'm going to have this camera right here, okay? So I'm going to unplug my USB-C port, because remember, C is auto-negotiating. So it should negotiate for a higher voltage and more current. Let's see how much current comes off the motherboard. Now this is not a lackluster computer. This is a Dell G717. So this is a nicer computer. This USB-C port should be able to put out some amps. Let's see what it can do. Guys, this camera will be right back. Just hold tight. All right, there we go. You see we lost some of that video. All right, okay, let me hook up the USB-C the way it was. All right, here we go. So we got that guy. Am I going crazy, guys? There it is. Here it is. All right. All right. You guys still with me? Okay. USB-C is up. Now I'm going to try the good USB-C cable. And let's see how many amps I pull. So I'm sitting at 5.09 volts right now. No negotiating off the laptop. Let's see if when I plug in my phone, if that changes. Okay. Well, I definitely learned. Okay, first off, it threw USB device not recognized. It's pissed off. It's really pissed off right now. So I've got 5.06 volts at 0.1 amps. Not very much at all. I thought it was going to be way higher. So it's actually slower charging off this USB-C with this adapter. So let's unplug the adapter. It says it's going to take 57 minutes for my phone to charge. So let's see if I plug the USB-C straight into this without this. Let's see what I can do. It says 38 minutes until full. So it did negotiate. 60 minutes until full. It's getting worse. Okay, guys. Charging off a laptop an option. That's horrible. Okay. Camera? Hold on, guys. Hold on. I'm breaking up because I'm connecting and disconnecting. Here we go. Boop. All right. Can you guys see me? We're still good? This camera here is not happy. Not happy at all. That's okay. Can you hear me? Not happy. All right. There we go. Okay, guys. So what did we learn? Get a good USB-C cable and use it. If you use anything else other than a USB-C, you are going to have some real problems, okay? So use a USB-C and use a proper charger. Now, you would think that that's common sense, right? But people use everything to charge their phone that shows up. I myself, I've been doing it. I've been using the wrong chargers to charge my phone. And because of that, I might be damaging my phone. And at the same time, it's taking forever, especially when I use my laptop. It takes forever to charge my phone, like hours. So what I can tell you is I've learned a lot about how the negotiation happens because I can see it happening with this little adapter right here. But at the same time, you can tell that different chargers definitely respond to loads differently. So some of these cheap chargers, all these ones right here, they have a purpose. Like one of them powers my little microscope right here. Who cares? Now, I might get rid of that one because that one, it was the one that took like 0.3 of an amp and just kept cutting out. I don't know. I might keep it. I might throw it out because those are garbage. Now, the ones that I was kind of impressed with are the ones like this Sodexo. It feels kind of heavy, but and there it goes. So I really dig these kind of chargers right here, especially when I'm traveling because, they pop up like that. You can hide the blades. It's much better when you're traveling. Plus, it's got 2 ports. It's kind of a win. It just takes forever to charge. So going forward, I think I'm going to use my USB-C charger, which I don't even know what I did with it. So I'm only going to use the USB-C charging. I'm probably never again going to use the USB 2.0, this style right here. It's a bad idea. It doesn't have enough current, and a lot of these chargers, these cheaper ones, these could be a fire hazard based on the amount of load, because your phone, these modern day phones, they pull a lot of amps. And this guy can't keep up, and it doesn't have circuit protection. Like this guy right here, it had circuit protection. It would cut off the output completely if I exceeded what it was rated for. These cheaper little ones, they don't cut off. They will just keep going and going and going, even if it's a dead short. So basically, that's what I was creating by increasing the load with these resistors, is I'm simulating a short or a device that is not supposed to be charged with that adapter. And it just kept going. The voltage just fell right off. And like I said, these guys have to charge at 3-point-something volts, all right? In the end, guys, all I want to do is tell you guys, please use the correct chargers. I just got to notice that I have an Amazon package. We have some very cool stuff that I'm going to be doing videos on tomorrow. Stay tuned, guys. It's going to be awesome. I'm going to change my workbench out right here. I'm going to get into some more circuit boards and stuff, and I got some new gear to test out. So it just showed up at my house. I'm very excited. Ashley Sunray, you are one of the winners that I did a drawing. Please write me at abetterbiomed@gmail.com and let me know your contact info so that I can get you what you won. I will mail it out tomorrow for you, okay? Everybody else, y'all have a wonderful weekend, okay? Use the correct chargers. They do matter. And I learned that today myself. Who knew, right? Anyway, guys, thank you very much for watching. And I'll see you guys tomorrow. Tomorrow I'm going to do a for my workbench. Cool stuff.